So suppose p of x is equal to 3x cubed plus 5x squared minus 3x minus 2. Given that negative 2 is a zero of that polynomial, suppose we're asked to find all of the other zeros. So one thing we can use here is the factor theorem, which says that if negative 2 is a zero of that polynomial p of x, that implies by the factor theorem that x minus negative 2, so in other words x plus 2, is a factor. Is a factor of p of x. Okay, so that tells us that this polynomial p of x, which is equal to 3x cubed plus 5x squared minus 3x minus 2, this polynomial is equal to x plus 2 times something. If x plus 2 is a factor, I want to squeeze the word factor over here, that means that x plus 2 can be factored out, so that the polynomial is equal to x plus 2 times some other polynomial. And we would like to solve for this missing factor over here. So the way we could do that is to take this equation and divide both sides by x plus 2. If we divide both sides by x plus 2, then whatever we get when we perform this division here will be equal to the missing factor. So that's the plan. Now, to actually perform this division right here, we do have the option of using synthetic division. You could use synthetic division. Long division always works. When you happen to be dividing by something of the form x plus or minus a number, you could also use the shortcut method, which is synthetic division. And I'm going to use that here. So if I set up the synthetic division, I would put the opposite sign, so negative 2, which is the zero of that factor, in the box here, and then the coefficients of this polynomial, keeping in mind that I need to include a 0 for any missing powers of x. So 3x cubed, 5x squared, negative 3x to the first, negative 2 for the constant. There are no missing powers of x in that polynomial. Okay, and I'm skipping a line, draw a line here. The 3 comes straight down, and then we do negative 2 times 3, so that's negative 6, and add these terms. So that's negative 1. Now repeat that process. So negative 2 times negative 1, that's positive 2, add these terms. So that's negative 1. Again, repeat that process. So negative 2 times negative 1 is positive 2, and our remainder is 0, which is what needed to happen. If x plus 2 really is a factor, then the remainder when we divide by x plus 2 should be 0. So that's good to see. This right here tells us that the missing factor, we can now fill in the blank, forget this question mark, the missing factor is 3x squared minus 1x to the first minus 1. Now, remember, the overall goal was to find all of the other zeros of this polynomial. So p of x, we know now, can be factored in this form, x plus 2 times 3x squared minus x minus 1. If we set that equal to 0, well, we could set x plus 2 equal to 0 by itself. We're going to get x equals negative 2, which is the solution that we already knew about. So really what we're interested in is setting this other factor that we just found using synthetic division, set this factor equal to 0. And this is the beauty of being able to work with division of polynomials, is because we were looking for all zeros of this cubic polynomial. If you identify one zero and divide it out, then now you've taken it down from degree 3 to degree 2. And okay, well, so degree 2, that's a quadratic equation, so we can solve that either by factoring or the quadratic formula if factoring won't work. And in fact, in this case, factoring won't work. we would need two numbers whose product is -3 and the sum is -1. It's not going to happen. So you could try and factor that if you want to, but it turns out this is not a factorable expression. And so, like I mentioned before, with quadratic equations, plan B would be to use the quadratic formula. Which, if you've forgotten, quadratic formula is opposite of b plus or minus the square root of b squared minus 4ac all divided by 2a. And so I'm going to apply that formula over here to that quadratic equation. So in that case, I'm going to have arrows kind of going all over the place, but I guess I'll get rid of this arrow. In that case, a is 3, b is -1, because that's that coefficient there, and c is also -1. It's the constant term there. So if you apply the quadratic formula, it's opposite of b, so that'd be +1, plus or minus the square root of b squared, so that would be +1, minus 4 times a times c, all divided by 2 times a. So this will be 1 plus or minus, this is -12, right, when you multiply this out. So 1 minus -12, that'll be 1 plus 12, so square root of 13 over 6. And so there are the two remaining zeros. This is a degree 3 polynomial. We were given one zero. We know there are two other zeros, and here they are from the quadratic formula.